Uh, okay. We are group 24, so we are gonna start our final presentation.
And you're...
I'm Takeru Okamura. Yeah.
Takeru.
So first, I'm gonna introduce the movie we choose. We choose the Fast and Furious 7, which was released 2015. This series is about skilled drivers who do risky missions, fight enemies, and care about their friends and family.
Okay.
So I'm gonna explain scene 1. In this scene, the car jumps horizontally from one building to another. So I calculated whether it's actually possible or not. So first, how far the car would fall.
You need to be quiet, okay? Next time, next one, okay?
So first, I calculate how far the car would fall. I assume the distance between buildings is 50 meters and width of the floor of the building is 15 meters. And according to my research, the hypercar can accelerate. The hypercar can accelerate 60 km per hour within 15 minutes. So based on this, I converted the speed to meter per second and use it to calculate the time it would take to reach the building. And finally, I calculated how far the car would fall due to the gravity during that time, and which was 44.1 meters. So this proves that it's impossible for a car to jump horizontally from one building to another. So next, I calculated how intense the impact is when the car crashing into the building. I assumed the car's weight is 1,500 kilograms, and the time of impact with the building is 0.1 second. First, I calculated the car's downward speed and used it to find the car's total speed. And I used the car's total speed and the weight to calculate its momentum. And finally, I calculated the impact force, and which was 507,000 newtons. So this is too huge for a car to withstand. So I'm gonna summarize my part. The distance the car falls is 44.1 meters, but the car can't fly horizontally between that buildings. Additionally, the intensity of the impact when the car hits the building is 507,000 newtons, but the car can only withstand the force of several tens of thousands of newtons, so which means the car can't stand this force. So in conclusion, it's impossible for a car to safely jump from one building to another. So I'm gonna show the video like this.
Okay.
Yeah.
What's the problem? Can you show the problem at the beginning?
Yeah. It's like what actually happened.
Yeah, but the movie.
Okay.
Do you have a movie scene?
Wait.
I don't understand the problem.
How can I go back? Like, 前面的. It is. The car jumps horizontally from one building to another.
Yeah, but then it's going down.
It's almost horizontal, right?
I don't see it. You need to show the problem
because
at the beginning.
I think one of them used this thing, so.
This is what I kept saying last week, right? You need to show the problem at the beginning. Okay, so car jumps out. They're driving a car in a building?
Yeah.
it's going down, no?
Yeah, but I think it's almost
It's
horizontal.
going down, right?
Yeah, this.
It's not horizontal.
It's
It was going down, right? You see the angle, right?
but it's not 44.1 meters, so it's kind
okay,
of
how
weird.
many? Yeah. How many
Yeah.
meters then?
Sorry.
How many meters then?
Like I calculate 44.meters.
Yes, but in the movie.
In like no more than like 10 meters.
Okay, this is the
Yeah.
problem. You need to identify the problem
Ah.
first. Okay, if you argue the falling down is too small, then you need to measure how much it falls and then compare to your calculation, right?
Okay.
So please try to do that in the report.
Okay.
Okay. And then another problem is this topic is already talked by I think at least 2 other students.
Oh, really?
Okay? So if you're going to talk about the same thing, you need to compare with previous students.
Okay.
So go back, watch previous student presentations, and then compare the difference.
Okay.
Okay, good. Other than that, presentation was good. Okay, what's your name? Your name? Okay, -1. Be quiet, okay?
I want to talk about the thing. The car
What's your name?
can.
Okay.
The character drive the car, escape the ground, and then collide the helicopter.
So what's the problem? Can you say the problem again?
The character hit the helicopter, and then he can move freely, and he looks like nothing happened. So I think this is impossible.
Can you show that? I don't see the problem.
I don't. I forget to.
So explain. Use the whiteboard. Explain, please.
就是说你的题目可以用画的，他说如果用影片的话。
You need to okay. Instruction says explain a program. Okay. So I want to see the program. So please explain the program.
What?
What happened? What happened in the movie?
The character drive the car, escape from the ground, and then hit the helicopter he want to let the helicopter destroy. So he drive it, escape from the ground, and then hit the helicopter, and then down on the ground, and then he can move freely, and then he looks like nothing happened. So I don't think it is possible.
Okay, so car is driving, right? Helicopter is flying, or helicopter is on the ground?
Yes. Not on the ground, on a high building.
Is it flying?
It's
Stopping.
hovering.
Hovering. Okay, so how can car hit the helicopter? Car is gonna
Because
jump
the it's a slide. He drive from here and then.
Oh, there's a slope.
Slope.
So and then car is jump. And then
Right.
helicopter. Okay. Now I understand what you're doing.
Okay. I want to. This is my assumption.
Okay, next slide.
Okay. I want to talk about the momentum.
Okay, fine. Next, please.
Okay. By my calculation, we get a final velocity, horizontal velocity of the car is 6.4 per miles per second.
Where did you get that 6,500?
The total mass, helicopter and plus the car mass.
So helicopter and the car got together?
Yes.
Okay. But you have to only consider the horizontal velocity, right? Are you only considering horizontal velocity? Can you go back? How did you get momentum? So car is jumping, right?
Yes.
So horizontal, you need to just consider horizontal speed. Please do that in the report. Okay. Anyway, let's go.
Oh, okay. And then I want to talk about how the force acting on the character. This is the actor's base, and initial velocity I use like Lester one, and then final velocity.
What was the mass of the helicopter? I forgot.
Helicopter was 5,000 kilograms. No. Okay, and then I assume the time of the collision was 0.2 seconds, and then we can get the force acting on the character was his mass plus the change of the okay. And then we know he experienced a force of 10,700 Newton, approximately 1.1 tons of force. I think I should say 1.1 tons weight of force. He may likely experience severe injuries. He might survive, but I don't think he can still move freely in reality.
Maybe. But I mean, car has. So this is like you're driving a car at 80 kilometers per hour and then hit the wall.
Yes.
They die? Do people die at 80 kilometers?
No. So I don't think.
But then nowadays you have a belt and you have what is that? This balloon right in front of you. How do you call it? Airbag. Also, how high are they?
Huh?
How high are they?
Yeah. What do you mean?
I mean, helicopter, how high was it?
Huh? I don't know. But this is only consider a horizontal velocity and force.
Okay, so you need to think about it. The car is jumping like this, right?
Yes.
You look at it, how many degrees? Okay, is it 45 degrees, 30 degrees, 20 degrees? And then calculate how high it is. And depending on that, the horizontal velocity will be lower because you need to jump up. Right? So if it's not 100 kilometers per second, you need to cosine there.
Oh, yes.
Okay? So the velocity is lower and then we calculate, okay?
Oh.
So I need two things in your report. The height, how high it is, and also calculate the impact if the person is falling from the high place, right?
Okay.
So that impact may be larger. And then also cosine and height. Yeah,
Cosine,
those
height.
two things please put in a report.
Okay.
Okay.
Next one.
You are Esther, right?
No,
Edward.
Edward. So, in this scene,
Yeah.
the team jumps off from an aircraft with their vehicle, and when they're about to hit the ground, they launch or they pull out the parachute so that the cars can land safely. However, the problem is that the parachute is too small for the car to be able to land safely and in a controlled manner. So since the parachute is too small, the area is too small, the drag force generated by the parachute will not be able to fully counteract the gravitational force. Therefore, the car will fall down too fast and end up being damaged, if not completely. So here's what we know. The average mass of a car, which is 1857 kilograms, the gravity, the drag coefficient for a dome-shaped parachute, which is 1.5, and the density of air.
Esther, how big is the parachute?
That big.
Go to next, please. Oh, okay. Fine. Okay.
So these are the two equations we will be using to figure this out. So the first equation is the drag force equation, where it is 0.5 times the coefficient of the parachute of the drag force multiplied by the area of the parachute and the density of air, and then multiplied by the velocity in which we want the car to slow down so that the car will not get damaged. I will explain this later in the next slide. And the second equation is Newton's second law, where force equals to mass times gravity. And for the car to land safely, the drag force generated must be equal to the gravitational force. So we get the equality where the gravitational force is equal to the drag force. And here's the process. And the velocity, I assume, for the car to land safely and without any massive damages is for the car to fall down at a rate of 5 meters per second. And any more than that would be likely to damage any vital components of the car. And in the end, we find that in order for the car to land safely, we need a parachute with an area of 792.28 meters square.
How did you get that?
So
Okay, so
yes.
the velocity and then you calculate it. Okay.
Yes.
Fine.
And from the picture, from one of the scenes, I assume the length of the car to be 4.5 meters, since that's about the average length of it. And the diameter of the parachute is roughly 4 to 5 times the length of the car. It's a rough estimate, since I can't clearly find another scene with this. So this is the best image I've got. And in the end, we find that the radius of the parachute is 10.125 meters, and squared that and multiplied by pi, we get 322.06 meters square, which is not nearly enough to cover the total area needed.
What was the total area you needed?
The one where the parachute needs to... Oh,
So 722. So just factor of 2. This is the total area you need, right?
yes.
So factor of 2. Did you consider how far is the car and then parachute?
How far?
The distance. Because you're here, right? You're here, and the car is here, parachute is here, right? The object closer to you look bigger, no?
Oh, you mean like, since the car is like closer to the camera, it might appear bigger. Like, yeah, I did. That's why I said like 4 to 5 times. Because if you take the car, it looks like 3 times, right? If you take the car and you try and measure the parachute, so I added like 1 of it to make sure that the parachute is actually big. But
Right?
in this case, even if I added a bit more to it. It's still not nearly enough to cover the area needed.
Okay.
So in conclusion, with an area of that size, the car will experience, if we plug it back into the equation, the car will experience a fall speed of roughly 7.84 meters per second, which could cause massive damages to the car, causing the mission to be a failure. Vital components like the fuel tanks, the exhaust system, and the suspensions and wheels might be broken. Even the frame and the windows could be cracked and deformed. However, stunts like these have actually been done in real life. I found a video where the Humvees are dropped from an aircraft and they land safely. However, the equipments they use are a lot, such as the suspensions and these cardboard-looking things, which their purpose is to cushion the fall and make sure the landing isn't as rough. However, in the movie, there is no such equipment. The only equipment they use is a parachute, and they somehow manage to land safely on the road. Even the shape of the Humvees, which is like a box, similar to a box, makes it so that it can fall down in a controlled manner, unlike the streamlined shape of a car, of an average car, where if we were to drop it in the mid-air, it would cause it to move uncontrollably. And finally, I made a video demonstrating how it would actually look like if the car were to, if the scene were to follow the laws of physics. So as you can see, I attached like a parachute, a makeshift parachute onto the item, and it just fell down. So that what it would look like. And these are the references I used.
Very good.
Thank you.
Okay, so this is a very good presentation. Okay, but then you just need a little bit bigger parachute, right?
Yeah.
700 square meter, then it's okay.
True, but also, but I think they would need a bit more equipment other than a parachute, because they only use like a car.
Yeah.
So even if like,
Okay, so
yeah.
I have two questions. Can you look into how big is a parachute for that military vehicle, and then check with the calculation? So according to your calculation, that's 700 square meters, right? So can you check how big it is?
The parachute?
Yeah, that one. How big it is? Can you look into that? And then compare with your value. Okay?
Okay.
That's a parachute, right?
Yeah, that's parachute.
Okay, so can you compare? And then second, then how did they shoot this scene in the movie?
Oh,
So
in the movie.
In the movie, you see the car is going down slowly, safely, right? So how did, if you say what you calculate is true, then how did they shoot this scene in the movie? Can you look into that?
Okay.
Maybe is it a CG or is it car smaller or something like that?
Mm-hmm.
Okay, thank you very much.
Thank you.
Very good. Okay, next question, please.
Hi everyone, I'm Yuki.
Yuki, okay.
Yes. And I'm going to start my presentation. And as you guys watched earlier, this is my scene.
You mean jumping from a building or no?
The ambulance, like diving off the bridge and crashed to the small drone.
Oh, okay. So drone is the enemy? So they're trying to
Yes.
destroy the enemy?
Yes,
Okay.
exactly. Oh. And this is the scene of Hobbs driving the ambulance off a bridge to destroy the drone. And this analysis will focus on two key physical aspects: projectile motion, ballistics, and aerodynamic stability.
What's the name? There. What's the name? Name?
Leon.
Leon, you're -1. Okay. You guys sit separately. Leon, come here. Sit in front. Leon. Now. Now. Okay. Go ahead, sorry. Can you explain a program? So what is the
Um,
program?
You mean it's nearly impossible because the drone is so fast, and then the ambulance is just jumped off the bridge and hit the drone.
Okay.
Okay. And then, okay, the first one. When an object leaves a horizontal surface with some initial horizontal speed and is only influenced by gravity, it follows a periodic trajectory. The motion can be decomposed into two parts. One is horizontal direction, and two is vertical direction. And here is the detail of calculation. And then these are the assumptions and some formulas. And if you assume the object is launched horizontally from the height y0 and has no initial vertical velocity. And to find the time, I calculated the time nearly equals to 1.65 seconds. In about 1.75 seconds, the ambulance hits the ground. And then I calculated the x, the horizontal distance traveled, and it's nearly close to 29.2 meters. And without air resistance, the ambulance would land roughly 29 meters away from the base of the bridge.
Mm-hmm.
And in terms of targeting the drone is a small, possibly moving target on the order of 1 to 2 meters in size. Even a slight variation in initial speed or angle leads to significant deviation in the landing point over 1.75 second flight. This is under ideal condition, like no air, the resistance, no rotation. And realistically, achieving pinpoint accuracy, hitting a small moving target at exactly the right moment is extraordinarily difficult. And then second one is aerodynamic stability. Here's the two steps. Step one is the existence of air resistance. Step two is lack of altitude control. Step one, the existence of air resistance. In reality, the ambulance, like large and box-shaped, experiences significant aerodynamic drag. Drag force is this, like this. And it depends on air density, rho, drag coefficient, CD, and front area A, and velocity V. And ambulances have large frontal areas and can have high drag coefficient. This results in sustaining drag, which slows the horizontal velocity and introduces the unpredictable deviation from the ideal predict path. This is the demonstrate video I made. So,
It's a drone.
I mean, because it's hard to make the drone, so I use the eraser on the ground, the black one.
Oh, that's drone?
Yeah, no, yeah.
Okay.
I mean-
That's a movie.
Well, I just wanted to explain it's really hard to hit the small things. Yeah. And earlier we discussed how the movie scene require extremely precise timing and positioning to illustrate how challenging this can be. And then this demonstration conclusion is by replicating a much simpler scenario, we've seen how challenging it is to control projectile trajectories. The film's scenario ignores these difficulties to create dramatic, but physically unrealistic moment. And the integrated conclusion is our ballistic impossibility, aerodynamic instability, and practical outcome. So the conclusion is this scene shows that attacking a drone with an ambulance is physically impossible. it ignores basic physics laws and it unrealistic. Therefore, this portrayal should be seen as fiction created for entertainment purposes. Thank you.
Okay. Very good. So how did they shoot this scene? So at the beginning you showed the scene, right?
Yes.
That's
Yes.
not using real drone.
They using a real drone, but I think just this is just for entertainment, because it's really hard. It's nearly impossible to hit the drone.
Hmm.
Yeah.
Hmm.
Mm.
But the ambience is very big, right?
Yeah, it's kind of big.
So ambience just need to block the path of the drone.
Mhm.
So maybe just in your calculation,
Uh-huh.
maybe,
Yeah.
maybe. So in your calculation, you're assuming a point-to-point crash, right?
Yes.
But then ambience is big.
Yes.
So it might, it can also crash into the head of the ambulance or the tail of the ambulance. So there may be maybe 1 or 2 seconds of a window to hit it.
Exactly. But
What I feel.
as you can see, like a 1 meter per sec difference in initial speed will shift the impact point by about 1.667 meter horizontally. Like it's big difference. It's big.
Okay.
So I think it's hard to hit the drone.
Okay. Can I ask a question? Second part. So how much difference does it make?
Second part. Which part?
Just before this. Air resistance.
Ah.
So how much difference does it make?
I mean, actually, I haven't calculated this. This is just for reference.
Okay.
Oh.
Fine. Okay. Okay. Good. Very good.
Okay.
I like your presentation.
Thank
Okay,
you so
thank you
much.
very
Thank you, Professor.
Okay. Next is
I'm Haiwen, yes. The bird is on the cliff edge too long time. Okay. At 2 minutes 4 seconds to 2 minutes 20 seconds.
okay.
Okay, six is on the edge 60 seconds. The fact that it took so long to slide down means the center of gravity was at the edge of the cliff.
Yeah.
We observe this picture. The bird is 60 kilograms and power work is he 80 kilograms and the bird long about 12 meter.
Kilometer.
Yes, and the distance between power work and the bird center in the X is 3 meters. Just here to here. Okay. And the center of land is left land bird center it 0.015 meter. It's here. The yellow line. The force is here. And the edge of
Because pole is left, so the center of the gravity is also left.
yes, but it actually is don't need to calculus because they are all left than the edge. So the edge of the cliff is clearly not at their center of the gravity, because if the birds want to on the edge 60 seconds, maybe this falls at here. This
Yeah, it might be there. How do you know the red point is there? I mean, red point should be at the creek, right? I mean, the one part of the bus may be heavier than the other, right? If there's an engine there, the engine is heavier, right?
I serve.
In the previous slide, you said the center of the gravity is at the creek, right? Should
Yes.
be at the creek, right? So the red point should be at the creek.
But
That's what you said, yeah.
on the internet, I found the information is the center in the birth center is in the mid of the birth. Yes, just
Okay.
general birth is just
Okay.
general. And demonstration videos, the birds will fall off the chair very quickly, and like this.
Okay.
Maybe 1 second or more short.
Okay, I don't agree with you. Because can you go back?
Okay.
So how did you think they should do this movie? So apparently, so there's an engine, right? Where's the back of the bus? There, right? On the right side, right?
Yes.
So if the bus is staying here, that means the red one is at the cliff.
Oh.
That's-
Oh, you mean this at here?
No, at the cliff, yeah.
At here now?
Yeah, yes. Right? The pole is moving, right?
Yes.
But then at the same time, bas's angle is changing, right?
Yes.
So if the bus goes like this, the more weight to the left, right? So pole is trying to compensate by moving to the right, right?
Yes,
That's
yes.
perfectly possible. That's not against physics law.
But I found the information in the internet is the
Okay.
center of gravity is in the
That's average bus, right? We're trying to, so you're saying this bus is different, but then we're trying to find something unphysical, right? I mean, how do you know this bus is average bus? Right, they fill the gas tank, then the weight will be different, right?
oh maybe.
So you picked a. So how do you think they shoot this scene? Okay, in the movie, how did they shoot this scene? Can you figure out how did they shoot this scene in your report? Can you show the movie?
Sure, movie.
Well, actually, bus is not stopping, right? Well, actually, bus is falling, so it's okay. If the, as you said, center of gravity is to the left, then bus
Yes.
is going to fall, right?
Yes.
And in this scene, bus is falling, so that's okay. If the bus is falling, center of gravity doesn't need to be at the center.
I just mean it should be more quickly.
Okay, how quick? So this is physics, right? If you say it's too quick, you need to calculate and then show the number and then show, okay, 16 seconds is too long, right? That's how this works, right?
Oh.
Okay, so
Okay.
in your report, please calculate how quick, how many seconds. Okay, if you say it's too quick. Okay?
Okay.
Okay, thank you. Thank you, Haiwan.
Thank you.
Then Estelle is the last one. Okay. Jael.
Okay, so I choose the scheme is following the scheme 1.
Okay.
So the
Power
car
jumping, yeah.
will should somehow so jump to another building,
Yeah.
and they find out that their brake is not working. So they are trying to it's nesting. Fine. Oh, okay.
Oh,
Sorry.
okay.
The brake's not working, so the car is still going and going. So they jumped again.
Again?
Yes,
Okay.
but that's okay. So the car is under control. So they finally decide to jump out of the car to save their life. And is this? So they just jump, and somehow they just stop at the edge of the tower. I think it is impossible because they jump out of the car with a fast speed. The car is fly out of the tower, but they just.
Wait, look at the car. Car is
Okay.
almost going straight down, no? Car is going straight down, right? So that means car's velocity was very low. Here. It's not like Takeru, right?
I think it's because the car is crashed on the tower's wall,
Maybe,
so they will make some decretion of the speed
Okay, so
at the final time.
Okay. What did you assume for car speed?
Okay. So, where is the PowerPoint?
P, go down.
PPP? What is? Okay. So I sure the speed is 40 kilometers per hour.
Okay, it's not unreasonable.
Yeah. So from 16 to 40, and do some translation on the speed and calculate this one.
Can you explain what did you calculate?
I calculate the acceleration is 3.09.
How?
Because the speed is 11.11, and I use the low.
How did you calculate it?
That's 40 kilograms.
Okay.
And 20 is the grounding the distance.
How many seconds? 3 seconds?
There's 3.9 seconds. 3.67. Yes. And the time is about like in the movies. It's about the same time.
No, I don't think you can do that. You need to know the distance.
Distance.
Distance between the point he dropped off.
Yeah, I look like is like about 20 meters.
Oh, okay, you need to explain that.
Oh.
Otherwise, that information is very important. Without that, you cannot calculate this, right?
Because
you need to explain everything.
it's like this thing. You can see he jumped this at
You
this.
need to explain what you did, okay?
Oh, okay.
20 meters is fine, but I didn't like you skip that, okay?
Okay.
Please, you need to explain,
So we move on to the next part.
okay?
So to stop just at the edge of the tower, so we need 247.2 newtons force. Yeah, and we can see that he jumps scalding on the ground. So the only force it can be will be the frictions. Yeah, so we can calculate the coefficient to 3.09, and this is almost impossible because we have a reference, like it's the normal drive up with tires is only 0.928, so it's very huge, so it's almost impossible. Yeah. So for the conclusion is jumping out of the car doesn't make for a successful experiment. In the normal world, they will probably just get out of the tower with the car. Yeah. Thank you.
Did you make movie? Okay, no movie?
No.
Okay. The car speed must be smaller.
Smaller, okay.
Can you calculate how slow the car is? Okay?
Okay.
It stopped, right? So you assume the coefficient of 0.8, mu 0.8, then you can calculate backward calculation to get the car speed, right?
Okay.
Please do that in your report.
Sure.
Okay? And then Estelle, this topic is already presented by other students. So you need to look into that. Did you attend that class?
No.
No, right?
Yeah.
So you need to go back to look at the video and then compare your presentation with previous students.
Okay.
Because you are selecting the same topic.
Okay.
Thank you very much. You're back.
I'm Takeru. Lastly, I'm gonna explain the physics term. One is momentum. Momentum is amount of motion an object has calculated as mass times velocity. For example, the ball's momentum changed when it hits the wall. Another is ballistics. Ballistic is the study of how objects like bullet move through the air. For example, ballistics helps scientists understand how bullet moves through the air.
Okay.
That's all.
Thank you very much.
Yeah, thank you.
How many people are in the other group? Oh, we should switch. Sorry, we need to skip your quiz.
Okay.
Let's go to the other group. So can you prepare?